Good morning, good afternoon, good evening, and welcome to today's session. We're going to cover Nutanix's overview of the hybrid cloud vision and strategy. My name is Avinash Shetty. I'm Senior Director here at Nutanix. I've been with the company now roughly 7.5 years. Worked on various things within the product portfolio, and I'm currently responsible for the broader portfolio strategy as well. So let's just dive into what Nutanix is doing. Today's session is really going to focus on sort of the broader overview of Nutanix. We're going to cover a little bit about what we're doing on the on-prem side of the equation, how that extends to bridging between public and private clouds, and we'll talk a little bit about what we're doing natively on the public cloud as well. All right, so to kick things off, let's compare essentially what Nutanix set out to do maybe about 10 years ago. So about 10 years ago, we knew that the public cloud was really starting to gain traction. The likes of AWS and Azure, and to some extent GCP and OCI and other cloud vendors were starting to come about. And customers really liked that sort of granular consumption, that ease of use, that fractional bits of consumption within the public cloud ecosystems. And they were basically looking for an alternate way in terms of how they were operating their own private ecosystems, right? Which was the traditional 3-tier and so on and so forth. So back then, Nutanix started out and said, could we take what the public cloud was doing and replicate that for the private cloud ecosystem so that we could have essentially people who didn't want to migrate to the public cloud have a cloud-like experience, but do that on-prem. And really where we went down this path was in sort of consolidating and simplifying two services within the public cloud ecosystem, and that's compute and storage. So if you think about the world of AWS as an example, you're very familiar with the likes of EC2 and EBS, right? So you can consume these two services within AWS in granular chunks, grow them as much or as little as you want. And that's exactly what Nutanix set out to do on the private cloud side. So what we said is, we'll give you a cloud-like architecture, which is software defined, which is scaled out, and we'll provide two services on top of that, which is compute and storage, the likes of EC2 and EBS. And we as a company were hugely successful. The industry coined this as hyperconverged infrastructure, and we've basically been the market leader in this space for the last 10 years. Now, over the years, obviously, we've developed this private cloud and built more services on top of that. So what does Nutanix of today look like? So the Nutanix of today has everything from a built-in hypervisor to data services, to database management, and so on and so forth, no different from what you'd expect in a public cloud environment. So when you're in AWS, you don't really care about the hypervisor, you don't even know it exists, or what you care about is that your applications are supported. Same thing is true for the Nutanix private cloud ecosystem. You can actually bring your own hypervisor if you have a vendor of choice, but Nutanix comes with a built-in hypervisor called HV. It's there, it's available for you to use. It's supported by a wide variety of applications, and you just need to spin up VMs or containers or whatever that you want within your ecosystem and actually be off to the races. Again, if you translate that back to the world of AWS, you have file storage, you have S3 buckets, you have a wide variety of data services on the back end. In the world of Nutanix, you get Nutanix files, which can actually terminate CIFS and NFS directories. You have block storage similar to S3. You have object storage, block storage similar to external scale-out SANs, or you have object store similar to S3. Now, if you're in the world of AWS, you're very familiar with RDS, which is about a $2 billion industry today for AWS. And really, if you think about what RDS does for AWS, is it's actually a Postgres database that's actually a managed offering by AWS to manage a wide variety of underlying data services, if you will. But if you look at the on-prem ecosystem, it isn't just Postgres. It's Postgres, it's SQL Server, it's Oracle, it's MariaDB, it's MongoDB, you name relational or NoSQL databases, and they all exist in most private cloud ecosystems. And there isn't a single unified database management platform that exists for this until now. Really, what Nutanix's database management solution is doing is consolidating all these different databases and providing a uniform method in terms of how you think about database management and so on. When you think about security, In the world of AWS, you have this clean concept called a VPC, or a virtual private container or connection. And essentially what it's really doing at the end of the day is protecting VMs and isolating them so that they don't interfere with other VMs or other traffic that they shouldn't have access to. That's no different in the world of Nutanix. We have a product called Flow, and Flow can microsegment the traffic exactly the way any VPC could. So we have policy-driven approaches in terms of how you want to secure traffic, inter-VM communication, external subnet communication, and so on and so forth, built right on top of the platform. If you're in the world of AWS, you're probably using AKS or EKS or Elastic Kubernetes services to actually build cloud-native applications and containers and so on and so forth. In the world of Nutanix, you have the Nutanix Carbon solution. And again, the idea is driving that same simplicity, if you will, within that ecosystem. So I want to basically have a network layer, a container layer running, and I want to have a container platform running on top of that. We have our own opinionated view of containers, but what you're going to see more and more from Nutanix is an open ecosystem where you can use our opinionated view of Kubernetes, or you can actually bring your own environment as well. So whether that's what we support today with the Google Anthos platform and GKE, and then more openness and more partner ecosystems, as you'll basically see going forward from Nutanix as well. The system itself is built from the ground up with security in mind. Everything from our hypervisor to our platform is extremely secure in terms of both the amount of exposure within the packages that we use, to having things like software-based key management, as well as encryption, as well as hardware-based key management and encryption support. So whether you're looking at rest, in-flight, or compliance-related security measures, we all have that built right into the platform as well. And then the table stakes, as with any cloud, whether it's public or private, what you expect is business continuity needs to be taken care of, whether that's snapshot and replication capabilities, whether that's sync, near sync, or async replication across multiple sites, or true full DR capabilities, whether site A goes down and you want to basically fully automate your DR stack, if you will. Again, all built right on top of the platform. So what does this all look like when you actually basically log on and actually manage that ecosystem? So let's walk through a few screenshots to kind of give you a feel for the flavor of what it is to manage a Nutanix private cloud ecosystem. So here we are. We're basically logging into our Nutanix Prism console. Prism is what we call our management console. And once you log in, you get a snapshot view of everything that's happening in your ecosystem. So you can see everything from the hypervisor that I'm managing, to my resiliency status, to the health of my overall system, a few performance metrics, overall resiliency, any critical alerts that I need to be looking at right away, and so on and so forth. So again, just, because it's a consolidated stack, because I don't have separate storage, separate management, separate file server, separate object store, I can actually get just a consolidated view of everything that's happening in my quote unquote cloud ecosystem right here through the single console. A little bit deeper, we have some advanced capabilities within the platform that actually can intelligently give you analytics or machine learning applied to this various data that's being generated within your platform, and actually give you meaningful insights on the back end of it. So here's an example of that. So when I log in, I can look at, based on my historical usage, I can immediately get a snapshot view of what I'm doing from a storage perspective and how much resources I have. How am I from a CPU perspective, or how am I doing from a memory perspective? So as you can see, I have about plenty of time on all three resources, but in certain situations, this being my demo environment, there's not a lot of traffic going on. But you can imagine many customers using this over time. The heuristics basically take care of ebbs and flows in consumption that might happen because of seasonality in your workloads, and so on and so forth. But effectively, that'll give you a predictive algorithm in terms of how much resources you have and how much runway you have before those resources will run out. Now let's assume you were in a constrained environment where you were running out of resources. You could click on this button that says optimize resources over here. And that will basically give you some recommendations. So it might tell you that you have VMs that are over provisioned. It might tell you you have VMs that are sitting inactive, or so on and so forth. So it's going to give you some insights in terms of actionable things that you could do to actually free up resources within your ecosystem. Another thing you could do is also think about, how you think about project planning. So here's an example of a cluster that I'm managing. This happens to be a HV cluster. I know that my budget cycles usually open every 9 months, so I got to do 9 months of planning ahead. And right now my budget cycle is open, so I'm thinking about what expansion do I need to think and plan ahead for. So here's my target of 9 months before my next budget cycle applies. Here I'm looking at my existing workloads, plus I've added 2 new workloads into this ecosystem. So I'm added, I know I have a project coming online for SQL, and I know I have some additional VM expansion projects that are coming online. The way I would add more is I would click on this button that says add or adjust. And when I do that, it's going to give me a screenshot in terms of, it's going to give me some resources in terms of VMs or types of workloads. When that workload comes online, what's the date that it would come online on? What are some other constraints that I might have as part of my expansion, and so on and so forth. I click save, and then I can add that workload here. When I click on this button that says recommend, what the system's going to do is actually going to calculate what is going to bring me into a good state. So if you notice before I was in all red, clicking that recommend button put me into a good state. And what it's essentially done is looked at my runway for 9 months. It's looked at the additional workloads that I need to add to my existing Nutanix cluster. And to basically hit that 9-month target, it's recommending I add some 12 additional nodes to my existing cluster so that I can accommodate the additional workloads. So this is really good in terms of budget planning, in terms of kind of looking ahead, in terms of projects that you have coming online. You can generate nice PDF reports, hand that to your management to say, look, if you want to accommodate all of these resources within this ecosystem, here's what that project is going to require in terms of funding. Now, when you think about security, as I mentioned, translating that to VPCs, I'm just a very visual person. I used to work in the world of security, and usually the world of security is looking through command line interfaces and dealing with ACLs and stuff like that. Instead, I can come here and immediately visualize that I'm trying to protect this VM stack in the middle. This happens to be my Zen desktop environment. So I can see I have a couple of Zen desktop management platforms. I have a couple of databases. I have a couple of domain controllers, and I can see all the inter-VM communication that's going on here. So I can see VMs communicating with each other between the VMs that I'm trying to protect. But then I can also see all of my incoming flows on the left-hand side over here, and then I can see all the outgoing flows from this VM application stack on the right-hand side over here. So if I basically look at this and I look at a subnet that I maybe either haven't classified or subnets that I have classified, I can basically immediately say, hey, why does engineering have access to this environment when we don't have any Zen desktop users within the engineering department? And I could immediately say these are users that shouldn't have access to this environment, and as a result should I could click on any one of those flows and block them, or I could say, yeah, this is legit, or I might find that this is suspect, and I could even do things like quarantine off VMs and stuff like that. So imagine if you get hit by a malware attack or something to that effect, I could just select a subnet and quarantine that off, or I could actually get down to the VM granular level and quarantine those VMs off, and so on and so forth, so that it doesn't impact the rest of my ecosystem. Now, as I mentioned, we not only provide security within the platform, but we also provide a whole variety of data services. So here's a screenshot within the files ecosystem. So we have some rich analytics built. So I have a file server running. I immediately can log on to my console and see all of the file shares that I'm basically managing, how much capacity I'm managing, what's the age of my data, what's my audit trail, what are these files being used for, sorted by size, and so on and so forth. So again, just giving you a rich set of analytics in terms of aging out old data, or audit trails, or whatever that might be. So any anomalies that might be in my ecosystem as well. So an example of an audit trail is I can basically look at any of my users and look at what are the kind of files that they've been generating over a certain period of time. So I can basically look at file analytics from a lens of a user or from a lens of a share and so on and so forth, and really basically start auditing and see when these files were created, who they were created by, what permissions did they have, so on and so forth. So again, really rich, really granular details as far as analytics is concerned. As I mentioned, our platform for database management called Era really extends beyond just the Postgres ecosystem that an RDS database would do. It really extends to everything that a customer would do on premises. So here you can see the customers managing an Oracle database, a Postgres, SQL Server, MySQL, as well as MariaDB. So you can see a wide variety of databases being used. You can see the number of databases itself, but also the number of clones they're managing, all of the copy data management that's happening behind the scenes through Era, and all of the savings that you're realizing as a result of Era doing the copy data management, and so on and so forth. So you can see about a 7x space savings here. We have full time machine capability. So if you get hit by a ransomware attack, we have the ability to go back to a specific second and restore your database from that point on, so that you actually, have a faster time to recover from a ransomware attack perspective. And then we have everything from, like I said, copy data management to full lifecycle management of the database to scrubbing of data should you want to hand sensitive if you want to basically scrub sensitive information before you hand it to your test and dev engineers so that they're doing patch management or whatever that might be. So again, just the entire life cycle management of a database end to end. And then you can get a little bit deeper, right? So when you get into this, you can actually manage individual databases at a much more granular level as well. Okay. All right, so that kind of summarizes what Nutanix does on the on-prem side of the equation to manage that database ecosystem. But then more and more customers are like, we get what Nutanix is doing. We get that Nutanix private cloud is sort of the equivalent of, say, an AWS or an Azure that I self-manage, self-host, and maybe not as services rich as you will to compare to some of the clouds, but for a vast majority of our customer base, it's exactly what they're looking for in terms of their day-to-day infrastructure management. But many of our customers say, look, there's always going to be a portion of my ecosystem that's going to live in AWS. There's a portion of my ecosystem that's going to live in Azure. And how is Nutanix helping me bridge the gap between my private cloud ecosystem and my public cloud ecosystem? And that's really where we've spent the last 5 years really building up that muscle, if you will, in terms of helping customers bridge the gap between public and private. And so some of the solutions in here is things like being agnostic to my automation and orchestration framework, looking at costs more holistically, whether that's costs that I'm incurring in AWS or Azure or on my private cloud ecosystem, and then looking at my budget allocation, my chargeback, showback capabilities also more holistically, so that I'm not tied to a specific cloud vendor or a specific cloud ecosystem. And last but not least, businesses that need to be compliant from a regulatory perspective, we're looking at all of these compliance checks in a more holistic fashion as well. So what does that all mean in terms of day-to-day usage? So let's take the example of a customer who's trying to take a repeatable process and automate it, right? So let's say I know everything there is to know about SQL Server deployments, how many backend databases I need, how much front-end web servers I need, what kind of ERP relationship there is, what is the scale requirements as number of users come on and off, and so on and so forth. And I take all of that logic and I put it into what is called a COM blueprint. So here, for example, I have an Era database manager managing a Postgres database with a Django front end and an object store backend. And you can see the relationship between these various VMs or ecosystems or containers. And you can also see the boot order. You can see how I'm basically starting with an ISO image to a full complete VM that's up and running. I can manage scale in terms of number of connections or number of users within each ecosystem before another VM gets spawned and created, and so on and so forth. So all that logic that I know in terms of how to operate an environment, I put into a blueprint. Once I have a blueprint ready, I can basically create this blueprint in a way that it could run on any environment. And then I could hit the publish button to actually show that up on a portal. Now you can imagine your end users who have no idea how to do a SQL Server deployment or this specific app deployment would just find themselves in a portal and they can pretty much click and deploy. So now we know that those users can actually have a repeatable process that is signed off by IT, and they could deploy this inside their AWS environment. They can deploy this into their Azure environment, their Nutanix environment, their non-Nutanix VMware environment, let's say, and so on and so forth. And really what Calm is doing behind the scenes is plugging into the APIs of these various ecosystems and orchestrating the whole deployment. You could even hook Calm up to ticketing systems like ServiceNow so that actually a service ticket is generated and that kicks off an automated deployment process as well. So again, no human touch, a fully automated deployment, regardless of where that deployment needs to live. Now, if you extend that, I have Calm orchestrating deployments on AWS, on Azure, on VMware, and so on and so forth. Now I want to look at my cost of running these various environments. So here I log on to my Beam ecosystem and I can immediately see the various environments that I have essentially resources running inside of. So when I log into Beam, I can actually log into my AWS environment up here. I can immediately see how much I'm spending on AWS. As you can see, I don't have a pretty big AWS footprint. It's pretty small, but I'm using some EC2 instances, some support, some containers, and so on and so forth. And then you can see, my spend analysis on a month-by-month basis in terms of the breakdown, right? So how much am I spending? What's most interesting is down here, which is what is my spend efficiency inside of AWS? So what does this mean? It means how optimized is my AWS environment versus ecosystems that I spun up VMs and I forgot about them, or I've oversized VMs, or I deleted VMs but I forgot to delete the underlying container associated with that VM, or the EBS volume associated, or the IP, or the load balancer, and so on and so forth. So all of that junk that usually gets left behind and I get a bill for at the end of every month, those are all things that Beam is looking to clean up. So here it's giving me a sense of what is my spend efficiency. As you can see, it's pretty high. But how would a customer go about increasing that? So they would click on this button that says save. When they click on that, there's another option in there called optimize. And one option within optimize could be something like this. So it says, hey, you have some underutilized EC2 instances. For instance, I have this VM that seems to be generating almost no traffic, not very heavily used. Currently, it's a T2 micro instance. And what the system is recommending is make it a T2 nano instance, which will save you $5.83 every month. Now you can imagine that's not a lot of money, but you multiply that by the number of VMs you're managing, multiply that by your monthly spend, and those numbers start to add up. So we have customers spending 7, 8 figures on AWS, on Azure, and for them, having to go look at each individual resource is never going to work. And so a tool like Beam could save them millions of dollars just by basically looking at things like underutilized. It could make recommendations in terms of usage patterns and suggest that you move this to a reserved instance rather than a spot instance, or vice versa, depending on how you're going to save money. So it's going to look at your historical usage patterns and going to make recommendations based on that. Now, this tool not just does that point of view for your AWS environment or your Azure environment, but it also does it for your on-prem Nutanix environment. So if I have Nutanix clusters on-prem, that same tool can extend and give me the same point of view in terms of my spend overview, in terms of my spend analysis, in terms of my capacity analysis. And this is another way to look at your spend efficiency, if you will. And so on and so forth, and give you recommendations, right? So in terms of how to future plan and future proof yourself as well. And the same things around save and optimize all come into play in the Nutanix ecosystem as much as it does in a cloud ecosystem. When it comes to security, we have that built into the platform as well. So you can imagine many of our customers need to be ISO compliant or PCI compliant or HIPAA compliant, depending on which agency or vertical you sit in. You might have different set of compliance checks. You might even have your own compliance checks that you need to run against and comply with. So we have about 500 or so and growing number of compliance checks built right into the platform. You can always add your own, and we run that on a periodic basis against your entire ecosystem, on-prem and cloud. So here I'm looking at my AWS environment, and I'm immediately seeing all of the regulatory compliance checks that I'm running against this environment, and I'm getting a sort of a snapshot view of how I'm doing against those compliance checks. So you can see the few green check marks tells me that few of them are passing altogether. Some are in yellow, some are in red. And if I click on any one of those, it's going to take me to a page where it's going to tell me exactly which compliance checks I'm failing and how to get back into compliance as well. And again, this system isn't just built for the cloud, it also extends to the on-prem. So here I have a Nutanix cluster. On-prem, I need to be PCI and STIG compliant. And again, you can see a lot of green checkboxes with one showing up as red. And again, I could take the same sort of remediation steps to basically get back into compliance. All right, so that's Nutanix on-prem covered, and then how we're helping bridge the gap between on-prem and public cloud covered. But more and more of our customers want to basically go down the pure cloud option, right? So in other words, they either have a cloud first mandate or they have some kind of cloud first strategies that requires them to actually consume more resources in public cloud ecosystems. So the first thing in this domain that we've done is we actually have our own cloud that we manage for customers who have a private cloud ecosystem running Nutanix, but the customer wants to be out of the business of managing a DR site. So imagine I'm a customer of Nutanix. I have my on-prem Nutanix cluster. It's up and running the whole time, but I don't currently have a DR site, and I don't want to be in the business of managing a secondary site that's going to basically mostly sit idle, 300 plus days of the year. And, it's really an insurance policy at the end of the day. So for those customers, we do have a service that we offer where we offer disaster recovery as a service. We actually maintain that DR site on behalf of the customer. The customer just signs up for the service. They tell us the cluster they want to protect in the public cloud, and then we take care of everything behind the scenes. So today we have this operational on a worldwide basis. We continue to expand with AWS, Azure, and other cloud vendors as part of that ecosystem to actually extend that service even beyond. But currently it is managed by a Nutanix ecosystem, and it is a Nutanix managed service. Now, for customers similar to our disaster recovery customers, we have another set of customers who also want to actually deliver desktops from the public cloud. So in other words, they don't want to have any on-prem desktop infrastructure in terms of VDI or end user computing in general. And so they can either stream applications or desktops from the public cloud ecosystem of their choice. So we have a solution called Nutanix Frame, which can actually stream these desktops from AWS, from Azure, from GCP to your end users. And we have customers who do a mix and match. Like, so for instance, we have customers who for the on-prem ecosystem use something like Citrix, but for the contractors and temporary workers will stream desktops from the public cloud. Or we have other customers who are like, my entire ecosystem is going to be public cloud driven, and hence including VDI infrastructure that's going to be streamed from the public cloud. So XiFrame is our desktop delivery as a service capability. And again, we support a wide variety of cloud ecosystems from which these desktops can be delivered. Now, the last two are kind of go hand in hand, which is really around how customers think about their cloud journey altogether, right? So in other words, we have customers who are AWS customers, we have customers who are Azure customers, but they don't quite know how to take their ecosystem from on-prem to the public cloud because that involves a lot of refactoring, making it cloud native, and so on and so forth. So there are many customers who are well down that path in terms of their journey, others who are just getting started and are looking for us to provide a solution in terms of how to get there. So our strategy there really revolves around how we think about our customers' journey. So if you follow the Gartner or the AWS paradigm, you probably heard of the 5 R's, which is rehost, refactor, re-architect, rebuild, replace. Now, I believe AWS has added 2 more R's to this ecosystem. But essentially, this is their way of saying, look, if there's any application that's on-prem that you want to move to the public cloud, you have to do 1 or 2 of these 5 to 7 things to get your cloud, to get your application to the public cloud ecosystems. our solution is a little bit more simpler than that. We look at customers who fall into three broad buckets. Customers who want to do SaaS, in other words, they just want to consume a service, and you'll see more and more of our ecosystem becoming a SaaS offering. So today we have with Frame the ability to stream desktops from the cloud, with Beam to do cost optimization on the cloud, with Zyleap to do disaster recovery on the cloud, and with Calm to do things like automation and orchestration on the cloud. Then we have another set of customers who are basically like, hey, I'm going down this container path and I just want an open container system, right? Whether that's on-prem with Nutanix, we have our Carbon capabilities that's going to be more extensible to a BOI, OK, or bring your own Kubernetes engine, if you will, ecosystem. But then as they go to the public cloud, what they want is a storage system that allows them to actually keep their containers abstracted. So in other words, it's very easy for me to spin up a GKE environment versus an EKS environment. It takes me nothing, and containers are mostly stateless these days. But what's really hard to solve for is how do I take my data, which might be sitting on-prem or might be sitting on one cloud, and how do I then transfer it to another cloud? And that's where customers get hung up. And what we're looking to do is really abstract that storage layer from the end user, right, or the container ecosystem. And that's really where Carbon's going to mature and evolve enough to actually abstract those ecosystems. But in the meantime, what we do have is the ability to take the whole IaaS stack and virtualize that and abstract that from any cloud. And we call that Nutanix clusters. So if you think about what is Nutanix clusters, as I mentioned, our private cloud ecosystem is taking this Nutanix software, which was built for underlying scale out hardware, right? So in other words, I have hardware that's rack, stack, and cabled. I layer Nutanix software, and I can build my own private cloud on the private ecosystem. If you think about what the public cloud is, it's nothing but racks and racks of servers running their own proprietary software, whether it's AWS software, Azure software, and so on and so forth. Really, what we're doing at the end of the day is taking a few of those servers that are already rack stacked and cabled inside the public cloud, and instead of using the cloud software, we're layering Nutanix software on top of that. But once we layer Nutanix software within those servers, we're then plugging that server into your native cloud ecosystem. So now I have a native cloud deployment and I have a Nutanix cluster deployment all running inside the same VPC. What does this mean for my end customer? Well, effectively, if a customer of Nutanix has on-prem Nutanix, they could pretty much click and deploy or click and migrate virtual machines or containers that they have currently running on-prem and seamlessly move them to the public cloud ecosystem. And not just move them to the public cloud ecosystem, they actually get to plug that into their existing cloud deployment. So if they already have a VPC, they can actually have a Nutanix cluster that's spun up inside an existing VPC so that it's actually native in the same subnet as my EC2 instances or my EBS volumes or my S3 buckets or my AWS Lambda ecosystem. So effectively, for all practical purposes, I have both AWS and Nutanix running in the same ecosystem. And what that allows our customers to do is effectively seamlessly migrate applications back and forth without having to refactor, without having to take on the risk of basically, migrating these applications. And these could be business critical applications and so on and so forth, and do that in a very seamless manner, and really have a choice for the application that's a mix and match of on-prem and on-cloud. So in other words, there might be certain applications that require AWS services or Azure services, and there might be certain applications that require Nutanix services, like whether it's Nutanix Files, Nutanix Flow, and so on and so forth. And they can really make a decision, in terms of what's the right fit for the application and what service they actually consume on the back end. Now, what's really interesting about the way we've designed this is that they don't actually have to change their relationships with their cloud vendors in any way. So if I'm an existing AWS customer, I continue to be an existing AWS customer, and all my credits that I have through that AWS purchase will still apply, and I can still apply it to all of the bare metal or AWS services that I will continue to consume within this. And so we're really not changing the paradigm in terms of how you consume, how you deal with your cloud vendor at all. But what's really cool is, and the real reason CIOs love this, is it allows them to abstract your cloud. In other words, I could take the same platform, engineering it for AWS, but tomorrow I might change my strategy to Azure or OCI or GCP, and I could seamlessly create another Nutanix cluster in any one of these other cloud vendors and seamlessly port those applications back and forth between cloud vendors or even back to on-prem, depending on what my business needs are and how my business needs are changing. And what's cool is during this application or migration back and forth, your Nutanix licenses also migrate. So the beauty of our solution in many ways is we made our licenses portable. So if you migrate a workload from on-prem to AWS, those licenses from your on-prem ecosystem also migrate to AWS. And then when you migrate that to Azure, those licenses will migrate to Azure as well. So again, we're not basically restricting our customers in terms of where they want to run their applications. We're not restricting them in terms of how they procure from us from a licensing perspective. We're all about openness and the willingness to for customers to run their ecosystems where they choose to run their ecosystems. So to quickly summarize, our portfolio is quite rich, quite diverse, but the way we really break down our portfolio and everything that I talked about in today's session breaks down into a few big buckets. The first biggest bucket, if you will, is our cloud infrastructure bucket. And that really talks about all of the infrastructure pieces that you need to manage a private cloud offering, if you will, right? So everything from the built-in hypervisor to the compute and storage services to our data services with files and objects and volumes to effectively extending that even beyond with security and disaster recovery capabilities, as well as our cloud services where we offer these same DR capabilities when as a service and so on and so forth. So that all of the infrastructure pieces, if you will, kind of sit inside that cloud infrastructure bucket. The second piece is our cloud management bucket, which is everything from our Calm automation and orchestration engine to our Beam cost optimization engine to our security central capabilities where we can actually show regulatory and compliance across multi-clouds to basic AI, ML, powered operations engine. So everything from like we said, a little bit of cost optimization to predictive analytics to all of that stuff that we kind of showcased earlier in the deck, all kind of sitting prettily in that cloud management bucket. Now, outside of these two main buckets, there's 4 solution areas that we focus on. One solution area is primarily dedicated towards VDI as a use case or end user computing as a use case, where we have our frame ecosystem as well as licensing that is per user. We have our cloud native bucket, which is really focused on our container solution with Carbon, as well as an open platform beyond that, where you can bring your own container ecosystem. Our third solution bucket is around databases and database automation. And with the Era product that I showcased a little bit earlier, that full lifecycle management of databases and providing that as a service in the future as well. And the last one is around unified storage with files and objects all consolidate together. So, if you have a standalone need for a filer or an object store, then that's our fourth solution bucket as well. The underpinnings for all of this is a unified control plane, which was Prism. That's the console that I logged into to kind of show you all of those various screenshots. So you have a single management plane that also has unified APIs, unified IAM, security, and the full lifecycle management of this ecosystem. So anytime you have to do patching or upgrades and updates, that's all driven through that Prism interface. So that wraps up the Nutanix broad overview. I apologize if it ran really quickly, and I do have a tendency to speak fast, but hopefully it gives you a sense of where we are as a company, what our vision is, and how we're extending this to not just the on-prem ecosystem, but also to various public cloud ecosystems. And you'll see a rich roadmap beyond this, which I didn't touch upon today, but stay tuned and happy selling. Thank you.